Non-metallic sheath cable, specifically type NMB, is not permitted for use inside of conduits, whether metal or polyvinyl chloride, in high-rise commercial buildings. This is due to several factors related to building codes, fire safety, and appropriate wiring methods for such structures. Firstly, high-rise buildings, generally defined as structures with 6 or more floors, have stringent fire safety requirements. The National Electrical Code, or NEC, sets specific guidelines for wiring methods to ensure the safety of occupants and minimize the spread of fire. NMB cable, while suitable for residential applications and some light commercial settings, does not meet the requirements for enclosed raceways in high-rise buildings. Secondly, the NEC addresses the use of NMB cable in Article 334. While it allows NMB cable in some types of construction, it restricts its use in structures exceeding 3 floors. This is because NMB cable is not designed for the environmental conditions and potential mechanical stresses associated with conduit installations in larger buildings. Thirdly, consider the heat dissipation characteristics of NMB cable. When installed in conduit, the cable's ability to dissipate heat is significantly reduced. This can lead to overheating, insulation breakdown, and potentially electrical fires. Conduit systems are often used to protect wiring from physical damage, but they also trap heat, making NMB cable an unsuitable choice. Fourthly, the fill ratio of conduits is a critical factor. The NEC specifies the maximum percentage of conduit space that can be occupied by conductors. NMB cable, with its flat profile and multiple conductors encased in a non-metallic sheath, typically has a larger overall diameter than individual conductors of the same opacity. This makes it difficult to achieve proper conduit fill and can lead to overheating and difficulty in pulling the cable. Fifthly, the type of insulation used in NMB cable is typically rated for a maximum operating temperature of 90 degrees Celsius. However, when installed in conduit, the actual operating temperature can exceed this limit due to reduced heat dissipation. This can degrade the insulation over time, leading to short circuits and ground faults. Sixthly, consider the potential for mechanical damage during installation and throughout the lifespan of the building. NMB cable is relatively flexible and can be easily damaged by sharp edges or tight bends in the conduit system. While conduit is intended to provide protection, improper installation or external forces can compromise the cable's integrity. Seventhly, the NEC requires the use of specific wiring methods in high-rise buildings to ensure fire resistance and prevent the spread of smoke and fire. These methods typically involve the use of metal conduit, fire-resistant cables, and fire-stopping materials to seal penetrations through walls and floors. NMB cable does not provide the same level of fire resistance as these approved methods. Eighthly, local building codes and regulations often supplement the NEC and may impose additional restrictions on wiring methods in high-rise buildings. It is essential to consult with local authorities and electrical inspectors to ensure compliance with all applicable codes. Ninthly, the ampacity of NMB cable is typically derated when installed in conduit. This means that the cable's current carrying capacity must be reduced to account for the increased heat generated within the conduit. This derating can significantly impact the design and cost of the electrical system. Tenthly, the grounding requirements for NMB cable may not be compatible with the grounding requirements for conduit systems. The NEC specifies different grounding methods for different types of wiring systems, and it is crucial to ensure that the grounding system is properly installed and maintained to prevent electrical shock hazards. Instead of NMB cable, appropriate wiring methods for high-rise commercial buildings include the use of individual conductors in metal conduit, such as electrical metallic tubing, or IMT, or rigid metal conduit, or RMC. These conductors should be rated for the appropriate voltage and temperature and should be installed in accordance with the NEC and local building codes. Armored cable, also known as NC cable, is another suitable option, providing a degree of mechanical protection and fire resistance. When selecting wiring methods for high-rise buildings, it is essential to consider the following factors. Firstly, the voltage and current requirements of the electrical system. Secondly, the environmental conditions, including temperature, humidity, and exposure to corrosive substances. Thirdly, the potential for mechanical damage. Fourthly, the fire resistance requirements of the building code. Fifthly, the ease of installation and maintenance. Sixthly, the overall cost of the system. Properly installed and maintained electrical systems are crucial for the safety and functionality of high-rise commercial buildings. Using the correct wiring methods and adhering to all applicable codes and regulations is essential to prevent electrical fires, protect occupants, and ensure the long-term reliability of the electrical system. Always consult with qualified electrical professionals to design and install electrical systems in high-rise buildings. For example, consider a 208-volt system. The wiring in that situation needs to be run with the right materials for high rises. An NMB cable is not one of them. The conductors must be rated to handle 208 volts in the conduit.